Hi, well, welcome to Inform Friday, and I'm Roger Curtis. I work for Historic Environment Scotland in the technical research team. And if you're new to this broadcast, this is a series of discussions about traditional buildings where we'll be presenting a short topic each time, followed by some live Q&A. And we're also going to introduce them to our Inform Guide series. So each session will be corresponding to one or more of our published guidelines. And these are short leaflets, publications giving technical advice for homeowners and covering the basics on a number of topics. And there's a kind of large core of slightly more longer and heavier reading for those who are interested, and we've give links and routes to get to that reading material as well. In our previous live, we talked about solid walls, their repair and insulation. And today, the second episode in the spring series is all about micro-renewables in the historic environment or with historic and traditional buildings. And we'll look at considerations that need to be made when looking at these a renewable system, and some of the systems that sort of suit older and listed buildings. As usual, if you'd like to ask us a question, you can do this now via the Facebook page or log into our YouTube channel with your Google account. Also, the event's going to be recorded and available afterwards to watch at your leisure. And if we don't manage your question today, we'll try and do this at the next session, or if it's something quite specific, you can email us at technicalresearch@hes.scot. Questions sort of vary depending on the topic, so we just try and get through what we can. And as you've noticed, I'm not Leela, who's the normal presenter. She's away, so myself, I'm covering in and helping out today with the detail and the real sort of technical expertise is Kenny from my team, who will go into the detail. But by way of introduction and context, then, why are renewables important for traditional historic buildings? And we know that energy efficiency fabric measures will only go so far in getting buildings and sites and all of us to net zero. And renewables will be a pretty important part of making up that difference. So as with insulation, every building can play its part and everything can be improved. And renewables will be part of that mix. There may be listed consent issues, and that will be a factor, but listed builder consent is about managing change appropriately, not preventing it. So there's many opportunities. And I think in Scotland, we should be proud over time of actually being almost in the lead in the UK, certainly with micro-renewables, really starting with in the 19th century with small turbines for large houses. This is a derelict micro-hydro plant dating from the late 19th century at a property in Berwickshire on the coast near Coldingham. And these were delivering electricity to houses in many parts of Scotland where you had good flows of water. But we're also forgetting that, in fact, Scotland's been using water power for centuries, from the Middle Ages until the 1930s, when Scotland used water power in many places, agricultural, industrial. And this shows our Burlet Mill in Angus, which went out of use probably in the 1930s, and it's now in its last stages of decay, which is a real shame because the infrastructure, the lathe, the mill dam, and all the other things that go with it are still in place, and most definitely could be used for some sort of power. But let's also consider the solar arrays that we can be putting onto listed buildings. Here's an example of a solar array on a listed building or ancillary part of a listed building. And this is happening quite a lot, subject to the right consents. And Historic Environment Scotland have been quite active in promoting the use of micro-renewables on our own properties. Specifically, this is at Crichton Castle in Midlothian, which is off the grid. There's no electricity at all, and this provides a little bit of heating for the monument wardens, and lighting and some of the other things that we need. And the fact that it's on the roof of a scheduled monument shouldn't be an issue. This is a modern concrete roof put in the 1940s, I think. And in fact, this array sits very comfortably. So just getting into the content of today, then, what we'll try and focus on is what's the most relevant for older buildings. That will be photovoltaic, possibly wind in the garden or close by. Solar thermal will definitely have a place. Biomass to a degree, although I think that is possibly changing. And we'll touch on heat pumps, which I think is probably being pushed quite strongly from industry and policy. I think, notwithstanding the picks that I showed you, we'll probably be quite light on microhydro. We won't cover combined heat and power. And then Kenny will go into a general discussion on how these technologies work and how they fit with other sort of support mechanisms out there for us. It's interesting, though, recently some legacy or older turbine systems have been reinstated. And in fact, where you've got a high fall and a steady, continuous flow of water over the year, these can be very, very effective indeed. But quite a lot of investment and probably out with the scope of most ordinary homeowners, but it does work in some places. And many community groups have set up such turbines particularly in the west of Scotland. So it does have its place. But I think I won't progress that too far, and I'll introduce you now to Kenny, who's on my team. He's an energy assessor, formerly worked for the Energy Savings Trust, and is very well versed in some of the domestic considerations in the use of microrenewables and what works. So welcome, Kenny. It's your first time on Inform Friday, so good to see you. And I'll hand over to Kenny, who'll run through. We'll try and take questions perhaps at each end of his section, or we'll just press on to the end depending on how the demand goes. Okay, over to you, Kenny. Thank you.
All right. Well, thank you very much for the introduction, Roger. Delighted to be here, and thank you very much for everyone who's tuning in to hear me talk about microrenewables in the historic environment. Let's get started then with solar PV. PV stands for photovoltaic. So these are, of course, the electricity generating type of solar panels. The image that you can see on screen now is pretty typical of a domestic system that you might find in Scotland today. Something along the lines of 12 to 16 panels, each being about 1 metre by 1.5 metres, something like that. These will amount to something along the lines of 4 kilowatts worth of peak output. So, you know, a powerful kettle and a bit more. And there will also be somewhere a inverter, which is a relatively small boxy component of the system, which will find itself in an attic or a utility space. And all that does is convert the direct current output of the panels into alternating current. Alternating current is just the form of electricity that's used in the grid and in household appliances. In very brief, what you're going to need to make this technology work, if you're considering it, is a roof or somewhere on the ground to put the panels. It should be facing something along the lines of southeast to southwest, ideally, with the minimum of shading, though east and or west facing systems can also work. So, traditional building issues specifically with solar PV. Well, obviously, we're putting something on the roof, and something I get asked quite a lot is, you know, what's the risk of damage to the roof covering? Inevitably, there's work going on up there, so there's always the possibility of a couple of broken slates. But as long as the installer knows his stuff, it shouldn't be a huge concern, and certainly nothing that can't be made good. I also get asked about the structural implications in terms of both the weight of the system and potential wind loading, you know, from the wind sort of kind of getting up underneath the panels. Unless you have a very significant underlying issue or a kind of historic issue with the roof timbers, this shouldn't really be a problem. If you do have any concerns, if there's been rot in the timbers before, if there's been a lot of woodworm, that sort of thing, you know, mention it to the installer, get them to have a look at it, and they'll be able to advise if you're getting into consult a structural engineer territory. But in 99.9% of installations, it's just not an issue. Maintenance is also something to consider. The panels themselves are more or less a maintenance-free technology, but what I mean is maintenance of the roof. which isn't to say that you can't get at the roof to maintain it once you have solar panels up there, but it's an additional faff, and it's probably going to cost you more money, because to get at the roof, obviously, you've got to take the panels off, you've got to put them back on again, and the connecting and disconnecting really should be done by a qualified person. So have a think before you invest in a PV system. What does my roof need done to it just now? What's going to need done in the next 5 or 10 years? Maybe the roof covering is coming up for renewal, and I would think about seriously bringing that forward to before you invest in a PV system to avoid the additional headache. Moving on, I suppose, to the more sort of airy-fairy aspects of this. Visual impact. Now, this is kind of beauty is in the eye of the beholder. Inevitably, there's going to be an impact on the character of the building, but it's kind of up to you. You know, you're going to be looking at these things. Are you happy with how they look? I mean, looking at the image that's on screen just now, I'd be perfectly happy with that. I think they look rather lovely, but it's kind of up to you. There are, of course, products such as solar slates increasingly becoming available, which are far less obtrusive visually. It's worth bearing in mind, though, those tend to be more expensive. So make sure to do your sums and make sure that the system is still going to make economic sense at that higher price point. You know, if financial payback is a main motivator for you. Obviously, the local planning department may also have an opinion. Happily, most of us are covered by permitted development rights when it comes to solar PV. Unless you're in a flat, a conservation area, or a listed building, solar PV can fall under permitted development. In those other circumstances, you will need planning permission. Happily, though, planning departments are quite well disposed to microgen technologies these days, especially, say, if you're in a conservation area, as long as you're not looking to put PV on the main elevation, which is the one fronting the street, and sometimes even if you are, it sort of just depends what the character of the area is. Usually, permission should be forthcoming, but ultimately that's down to the planning authority. Finally, just a wee sort of note on performance. So one interesting feature of traditional buildings, often they have quite complicated roofs. You know, there's different sort of roof elevations pointing in different directions. There are, you know, crow steps, there's tall chimneys, there's dormer windows, etc. and so forth. And these have the potential to shade a solar PV system during all or part of the day. And even if you've got a little sort of narrow shadow like a chimney, there's potential for that to have an outsized impact because of the way a solar PV system functions electrically speaking. There are technical fixes to that, though. I'm not going to go into the detail of this, but it's just something to make sure your installer has taken into account if you think, say, there's a chimney that's going to cast a shadow that's going to scroll across the system over the course of the day. And at that point, they'll probably start talking about things like microinverters or voltage optimizers or that sort of thing. As long as it's been taken into account at the design stage, you're fine. And finally, a wee note on our old friend, the Energy Performance Certificate. So, because solar panels generate electricity, because electricity is quite expensive, and because ultimately what an energy performance certificate most cares about is how much it costs to run your property, generally solar PV or indeed a wind turbine will have a big impact on your EPC band. And with minimum energy efficiency standards on the way, that's definitely something we should all be aware of. So it may be, in fact, that of the options available, a solar PV system could be the cheapest and least disruptive way for your property to meet that minimum standard in years to come. It does fly a little bit in the face of the established logic of energy efficiency, which is fabric first. But again, you know, if it's the cheapest, least disruptive option, I would certainly be thinking about it. Just something to be considering. Right. I think that pretty much covers solar PV for now. Again, I would emphasize that I'm going to sort of fly through the technologies in aid of getting to as many questions as possible. So I'll progress now onto wind turbines. So the typical wind turbine in the domestic or sort of light commercial setting in Scotland is a bit like what you can see on screen here. This is on the Isle of Westray. It's a freestanding turbine. Typically, there'll be something like, you know, kind of 4 to 10 meters tall, a peak output something in the region of 2.5 to 10 kilowatts. What you need to make it work is exactly what you would imagine. You're after an unobstructed site, especially unobstructed in the prevailing wind direction, which tends to be something along the lines of west or southwest in Scotland. And you'll also need sufficient average wind flow. as a good rule of thumb, about 5 meters per second or more is what you're after. And because most of us tend not to know what the average wind flow is at our postcode off by heart, the Energy Saving Trust actually have a handy predictor tool that you can use to look that up. Although obviously caveat that sort of local conditions kind of prevail. You know, if you've got loads of that wind flow, but your property's covered in trees, that's probably not going to be the best. Specific traditional building issues, not really a huge amount, to be honest. Honourable mention perhaps to the sort of wee building mounted turbines that were popular maybe 10 or 15 years ago. You may have seen these around. They were found not to be particularly effective in terms of, like, you know, paying back their installation cost with the energy that they outputted once all the sums were done, which is why you tend not to see them as much these days. And I would also have a bit of a concern, about attaching something that's going to produce a sort of constant low-level vibration to a kind of masonry wall that's been there for a couple of 100 years. I'd just be a little bit sort of concerned about that. So I'd maybe steer clear of those. Visual impact obviously is a consideration. Again, it's something that you are going to see, perhaps not as much as solar PV because it is going to stand apart from the building, but also, yeah, very much something to think about. In terms of what the local planning department is going to think about it, chances are you will need planning permission for a wind turbine. They can be covered under permitted development, but it's unusual. For it to be covered by permitted development rights, you need to be more than 100 meters from the curtilage of somebody else's property. And if you have a listed building, it needs to be more than 100 meters also from the curtilage of your property. And that, I think, pretty much covers wind turbines. So that's your whistle-stop tour of the microgeneration technologies. No mention of batteries, I hasten to add. We'll come back to a quick chat on those later on. But for now, do we have a few minutes for questions, Roger, or shall we press on?
Let's just have a quick look at the question situation. Got a bit of mouse confusion there. Right. So Home Jamie on YouTube. He's quite high up, 1,400 feet, Cairngorms National Park, and they do not allow wind turbines. I understand why. Is there a hidden micro option for a new build? Ooh.
Interesting.
I don't know, Kenny. What do you like on planning legislation in national parks?
Well, the planning authority, what the planning authority says goes, I'm afraid. However, I actually do happen to be aware of an option, the one that I know of is like a roof ridge wind turbine. I would whack that into a search engine, see who comes up. The company that I'm aware of are called Ridgeblade, and these essentially look a little bit like a sort of historic ventilator that's kind of linear along the apex of the roof, but actually hidden within there is some version of a wind turbine. It takes advantage of the shape of the roof to improve the output as compared to sort of kind of older style kind of building mounted turbine.
And you get vertical axis turbines as well, often made for marine use. So it might be something that might be an option, but you might have to chat that through with them and see where their cutoff point for size is. Okay, another one from Francis on Facebook. We own an old mill and still want to keep the original wheel, etc. Issue seems to be low head, high flow. Are you aware if there are options that don't require the high head and who to get advice from? Really good question. Thank you. This is the one that I kind of wrestle with, and it kind of makes me angry because the industry just ignore all this stuff because they want thousands of tons of poured concrete and, you know, really big civil stuff, which is fine. But what about the medium to small scale? And the answer to the question is I don't know. But if you had a wheel that was able of pushing around two large limestone stone things 3 or 4 times a week, crushing grain, I can't believe there's not enough power to spin a dynamo or a turbine. It's all about the gearing and the speed at which the thing sits and how you procure it. It can get a bit Heath Robinson in this area, but I think there's nothing wrong with that. There's no shame in it. Anything, I mean, most water wheels, traditional wheels, the head is about sort of 6 foot or 4 foot or so, and that'll easily power a small turbine with a sort of 4 or 5 inch bore pipe. Navitron do a little Chinese little turbine thing. do one which works on modest flow as well. So I think this is an interesting one, and so please stay in touch. We'll have a separate chat. Another one, Francie on Facebook.
The options are out there.
Yeah, we've got to make it work. Right, Francie on Facebook. Can you install solar panels on tenements? Kenny will come to that. Actually, the answer is yes. It has been done. It's been done in a listed context, and Kenny will talk about that. I think there is potential there. So thank you for your question. Are you going to talk about Facebook? Are you going to talk about hydro technology? As I said at the beginning, I love to, I want to, but its application for Scotland, urban Scotland, is modest. But yes, we can pick up on that at the end, maybe. So let's move on to the next section. But thanks for the questions so far. Keep them coming, and let's move on and get through it.
Great. Yeah, that sounds good. I love talking about hydro because it's great fun, but it's a bit niche. So if we've got time at the end, we'll be right back to it. For now, let's bash onto the renewable heating technologies. And relevant to your tenement question, we're going to start with solar thermal. And the typical system in Scotland looks a little bit like this, although this one is in a more unusual circumstance on the roof of a tenement than you might normally expect. This is hidden away. I think the building might in fact be listed, but it's hidden away in the valley of the roof, which is why it's been deemed acceptable. So this sort of solution, certainly from a planning point of view, is what you're looking at if you're in a sort of heritage context and you want to install on the roof of a tenement. Back to solar thermal technology for now, though. So what these are is roof-mounted heat collectors, and that's most of what a solar thermal system is, to be honest. Besides these, there'll also be flow and return pipes, which will connect to a hot water cylinder somewhere in the property, and these circulate a heat exchange fluid, often referred to as glycol, but for all intents and purposes, water with antifreeze in it, which takes the heat from the panels and dumps them into the hot water cylinder, where it will hopefully be useful. Important note, first of all, because the heat resource that's available in winter in Scotland is just not that huge, as you may well imagine. This is not a central heating system, nor is it a year-round supply of hot water. It's a supplementary source of hot water. You're likely to get about 50% of your annual demand from a properly sized system. So that's worth bearing in mind. What you're going to need to make it work, it's what you'd imagine. It's similar to solar PV. You're after a sunny spot on the roof, and you should also have a think about where your hot water is coming from. Here's the example. A lot of modern households, they're not using a lot of hot water from their hot water tank if they still have a hot water tank. You know, if you've got a kitchen full of cold fill appliances, if you have an electric shower, if you don't wash dishes very much by hand, your hot water demand from your heating system is probably fairly negligible, in which case there's going to be very little point in something like solar thermal. If, on the other hand, you're washing dishes by hand, you've got a mixer shower, you've got a hot water cylinder already, etc., solar thermal could be worth considering. Your specific traditional building issues are quite similar to solar PV. The visual impact and planning considerations are also very similar. Solar thermal, however, has the notable advantage of generally being smaller. From a size point of view, a thermal collector, you're looking at maybe a bit more than a meter squared worth of collector for every occupant of the property. So that might be useful if you're trying to sneak it into, for example, the valley on a tenement roof, which helps to make it less obtrusive. And I think we'll sort of bash on from there to biomass. So, first thing to cover when we're talking about biomass heating, what are we talking about? And it's not what's on the screen just now. Humans, of course, have been burning biomass for thousands of years. But generally, when we're talking about biomass heating as a sort of renewable heating technology, we're talking about something a little bit more sophisticated. Usually a boiler burning logs, chips, or pellets, of which pellets are by far the most common option in the domestic setting. So that's what we're going to focus on today. Just to head off a question that we'll definitely get. In theory, biomass is a sustainable option. The idea is that as the tree is growing, it's pulling carbon in from the atmosphere, and when you cut it down, and then burn it, you're merely releasing that same carbon back into the atmosphere, as opposed to burning a fossil fuel where you're digging up carbon that has been sequestered for millions of years. This does require that your fuel is sustainably sourced. It needs to be from woodland that is sustainably managed. Therefore, I'd suggest as a first step, have a look at the biomass suppliers list. The suppliers on there have to jump through a number of hoops to prove that their wood fuel is sustainable. So that's a good first step. And also, it's not the worst idea before embarking on an installation to get some quotes as to what price you're going to pay for fuel. The typical system then. So biomass, I would say there's less of a typical system than, say, with sort of solar PV. This is a good example. So this is a little bit bigger than what you might have in most domestic properties. This is the subterranean boiler house of the biomass boiler at Roslin Chapel. The boilers themselves tend to be sort of fairly kind of boxy, nondescript, industrial looking things, coming down to the size of a sort of washing machine and sort of scaling up as needed depending on how much heat you want. These will plug quite happily into an existing wet system of radiators or indeed underfloor heating. I would say your key sort of consideration though really is fuel storage and handling. So you can either get pellets delivered in bags, which tend to be 10 or 20 kilos on the back of a flatbed truck, or in bulk by a tanker. For the bulk option, you are going to need a hopper or a converted outbuilding to use as a fuel store that then has an auger, which is essentially a motorized corkscrew which can feed pellets to the boiler. Or if you're using bagged pellets, you'll need to have somewhere sort of dry where those pellets are going to be able to remain dry, because moist pellets are no good for a biomass boiler. And crucially, you're going to need to make sure that the occupants of your property are happy moving around 10 to 20 kilo bags of pellets for the foreseeable future. So if you kind of elderly occupants, occupants with sort of mobility issues, that's a real thing to have a serious think about before you embark on this technology. Specific sort of traditional building issues with a sort of biomass boiler, it can be a really good option because it can give you low carbon heat without the strings attached that come with a heat pump, which I'll be coming on to next. There is potentially obviously a visual impact. Perhaps the boiler might be mounted externally, in which case it wants to ideally be somewhere inobtrusive, but usually they're mounted inside the building or in a purpose-built boiler house, which is what you're seeing on screen there. That's the boiler house at Kincardine Castle. And the eagle-eyed amongst you may have noticed the dog kennel adjacent. So I think those dogs there have the life of Riley in their nice warm kennel, but there we are. Another thing to bear in mind in terms of visual impact is the flue. Depending on the precise specification of the system, you may be able to reline an existing flue, or it might need an external flue. These can be sort of kind of shiny metal, fairly obvious. So depending on how extensive that is, again, the planning department might have a view. But if the visual impact is limited, again, there's a good chance it'll be covered under permitted development rights. It just sort of depends on how obvious the system's going to be and whether you are in a listed building or a sort of conservation area, that sort of thing. The other thing to bear in mind is that the units themselves are fairly bulky. It's going to occupy some space. You'll need that sort of spare utility room. You might need to erect a boiler house, that sort of thing. But otherwise, excellent option, especially if you have an existing wet system of radiators and your property is perhaps on the sort of lower end of thermal performance where a heat pump might be problematic. Which brings me nicely on to the subject of heat pumps. So, we've all got at least one heat pump in the property already, I suspect, which is the humble fridge. Now, the fridge works by using electricity to run a compressor circuit. Not going to go into the technical detail of that today. That's not what we're here for. It uses electricity to run a compressor circuit, which moves heat out of an insulated box. A heat pump used as a domestic heating system works in exactly the same way. It uses electricity to run a compressor circuit, which pulls heat from the environment in some fashion. I'll come to that. and dumps it into the property, into a system of radiators, into an underfloor heating system, or even into warm air blowers. So what are our specific issues with traditional building? Here's the big one. So the bigger the gap between the source of your heat, which is the external environment, and the temperature of the water that you're circulating in your radiators or underfloor heating system, the harder the heat pump has to work in order to bridge that gap. So ideally, you want to have a low flow temperature in your radiators, and it should be quite a lot lower than what you might expect with a boiler. Typically, if you've got, say, gas oil boiler, or even a biomass boiler for that matter, the water circulating in your radiators will be at a temperature of something like 60 to 80 degrees C. And with a heat pump, that wants to be more like 30 to 50, and at most really 55. And what that means is that you're getting less heat output per radiator. And it's quite a bit less. The same radiator at 40 degrees will give you only 30% of the heat output as that same radiator will at 70 degrees. What that means is that all other factors being equal, you will need more radiators, or you'll need bigger radiators, or some combination of both. Or you might want to invest in underfloor heating, which is what you can see on screen just now. That's actually at a Historic Environment Scotland case study site where we installed underfloor heating alongside a ground source heat pump into a traditional cottage. A good term to get your head around when you're thinking about heat pumps is seasonal coefficient of performance. Now that sounds wordy, but that essentially refers to the ratio averaged out over the course of the year between electricity input to the pump and the heat output. And the higher that number is, the higher the efficiency is, the lower your bills are. And the lower the temperature of the water in your radiators or underfloor heating system, the lower that number is going to be. So that's where the sort of tension is. Therefore, it's likely that in a traditional building, you are going to have to do some modifications to the distribution system. You're going to have to upsize those radiators. You're going to have to add more radiators. You're going to have to invest in underfloor heating, something like that. However, because traditional buildings are often starting from a lower baseline of thermal performance, you're probably going to have to look at improving the thermal performance of the property as well. I won't go into this in a huge amount of detail today because that's been the focus of various other Inform Friday sessions that we've done, and it's the focus of a lot of our published materials. There's lots of resources out there which you can refer to. And chances are, I suspect, that you're going to have to attack this problem from both ends. So you're going to have to look at modifying the distribution system. You're going to have to look at improving the thermal performance of your property. And then you're going to have a think about the sort of design flow temperature of your heat pump. So there'll be a compromise to be made. So for peak efficiency, you might want a flow temperature of 30 degrees, but that's going to require you to do a ridiculous level of insulation, radiators festooning every wall, that sort of thing. So maybe you compromise at 50, you accept lower efficiency, slightly higher running costs, but that allows you to get away with a slightly lighter touch suite of insulation measures and maybe a more reasonable system of radiators. It's definitely something to sort of talk through in detail with your installer because every property is going to be different in this regard. As a final sort of take-home message before I kind of come on to the different types of heat pump, I would say there is no such thing as a building that is unsuitable for a heat pump full stop. But this is the big caveat to remember. It may be that the level of cost and disruption that you have to endure in order to make your property suitable for a heat pump makes it an undesirable option. So that's the sort of tension there is any building can be made suitable for a heat pump. It's just how difficult is it going to be? How disruptive is it going to be? And again, in a heritage context, if you've got a sort of listed interior where disruption is not what you're after, that makes that equation that much harder to balance. And it might be that a heat pump is just a step too far. So let's have a nose at the different types of heat pump quickly. So first off, air source heat pump. You've definitely heard about these. You've probably seen them around. They are ubiquitous whenever the government is talking about the renewable heating agenda these days. What you're looking at on screen is the external unit of an air source heat pump. And what that does is it uses those fans to draw air, I beg your pardon, over a heat exchanger, and the unit then pulls heat from the atmosphere. Your specific sort of traditional building issue with an air source heat pump, the big one we've already covered, which is that kind of complex equation between the heat output of the radiators, the heat loss from the building, and the efficiency of the heat pump. But in addition, with an air source heat pump, you're going to have visual impact to contend with. It's going to have to go somewhere. Ideally, it wants to go on a building elevation that gets some solar gain. So, a wall that gets some sun, because that actually does improve the efficiency a little bit. And over time, that's going to make a difference to your bills. And it really doesn't want to be covered up. I get asked this question all the time, can I put a cupboard around it with some vents in it? And, maybe if the vents are really, really sort of wide open, but I'd be really, really cautious about it. Because I have seen some very, very unhappy heat pumps that have been enclosed, and that enclosure has essentially turned into a blast chiller, with ice collecting along the bottom, and that's going to be a very inefficient system, a very costly system to run. So really, a heat pump wants to be out in the open, and certainly stay away from anything that's going to encourage cold air to accumulate around the unit. Planning-wise, generally, happily, an air source heat pump can be covered under permitted development. Again, unless you are in a heritage context. I think conservation area, you can possibly get it under permitted development if it's not main elevation, but don't quote me on that. Go and check the permitted development guidelines. That's your responsibility as the building owner. And listed buildings, I suspect you'll be needing planning consent for that. It's also worth noting that it's only one per building under permitted development. So if you happen to live in a block of flats and your neighbour's beating you to it and got the first air source heat pump for the building, your one will now need to go through planning. That may change in future, but that's the way the permitted development guidelines are worded at present. Finally, let's move on to ground source heat pumps. These work in a slightly different way. A ground source heat pump draws heat from the earth by way of a ground loop, which is what you see being laid in a trench in the image in front of you. There's nothing rocket science here. This is just a length of high density polyethylene pipe. Through that pipe is circulated a heat exchange fluid, usually referred to as brine, but again, for all intents and purposes, water with antifreeze in it. That will leave the pump at a temperature of maybe, I don't know, say -3, -4, -5, it'll come back at a temperature of maybe 0, 1, something along those lines. And from that heat exchange fluid, the heat pump will extract heat to then circulate in your radiators or your underfloor heating system. Because the temperature of the ground tends to be more stable over the course of the year, ground source tends to be slightly more efficient than air source. So it's worth having a look at, but it is considerably more expensive to install. Your traditional building considerations here, the caveat still applies in terms of heat loss versus heat output. Visual impact, this can be a really good technology for a heritage setting, because once it's installed, there will very probably be no external visual impact, because the unit itself will be internal and the collector loop will be buried. However, there's going to be quite a lot of disruption during the installation, as you can see in this image here, because installing the ground loop for a ground source heat pump is going to require a fair bit of trenching or perhaps a borehole. Archaeology might even be a consideration depending on your context, so have a think about that carefully as well. Also bear in mind that the equipment itself is very bulky. Well, I say very bulky, not very bulky, but it will need consideration. A ground source heat pump unit itself is usually something along the lines of sort of a small fridge freezer. And then in addition to that, you'll need a hot water cylinder. You will need a buffer tank. You'll need a brine vessel. You'll need pipework connecting all these things together. So it's going to occupy half of a kind of small utility room. So make sure you're discussing that with the installer up front. And that, I think, covers renewable heating for just now. Shall we stop for questions, Roger, or shall we push on to the end?
Yeah, there's a few questions come through, so let's have a quick rattle, and I'll be a bit quick, and I'll only shove some to you that really need a bit of expertise. So we did the tenement one. Integrated, so Grant on YouTube, what about integrated solar in old slate roofs? Yes, that's a fair point. You can actually get solar slates that you can set up directly on the roof. It does work in older properties. I've seen it on a couple of national park buildings as it happens, and I think that's one of cost. Would the solar slate fit the sort of traditional slating pattern that you're working on? But in principle, to answer your question, yes, it does happen, and I think that's probably going to be fine. Another question from Facebook, Applegarth Hall. That sounds a romantic location up in the North York Moors or somewhere. How far from the nearest structure does a wind turbine need to be? I don't quite know. I think there's a little noise consideration and what sort of garden arrangements you have. Kenny, any thoughts on that one quickly?
On performance-wise, it's a little bit how long is a piece of string. If you've got a quite a constrained site and it wants to be close to the building from that point of view, remember you want it to be unobstructed from the prevailing wind direction. So if your prevailing wind is coming from the west and you can mount it due north, or site it rather due north of your building, that might be okay. But if the prevailing wind is from the west and you are going to put this directly to the east of your building, did I get that the right way around? I hope so. That's going to be bad news because it's going to significantly impact the output of the system.
It's the eddies that the building create and how far those eddies carry on and affect the efficiency of the turbine. Okay.
Exactly.
Same correspondent again. Presumably the things avoiding planning permission only apply to develop. Or I'd never say we're avoiding planning, but there may be thresholds of micro renewables that fall beneath the planning criteria potentially. Only apply to domestic properties. Not necessarily. Agricultural buildings quite often have solar arrays now on the roof, and many agricultural buildings have a different planning journey than dwellings. So that might be worth progressing. Certainly, in many parts of Germany, nearly every big shed, big barn has a solar array on it. Right, moving quickly down the list. I'm conscious of time. Graham on YouTube, yeah, okay, YouTube. Are air source heat pumps becoming more neighbourly regarding noise? Kenny, noise.
The answer is emphatically yes. A heat pump from today will be much quieter than a heat pump was 10 years ago. These days, it tends to be a sort of very kind of quiet hum when the system is running. You're not going to hear it with the windows closed. And to be honest, if the weather is good enough that you are out in the garden on a quiet sunny day, probably the heat pump isn't running because, you know, there's that sort of kind of mismatch of when the heat pump is running, it's cold, so you're in the house. When the heat pump is not running, it's sunny, you're outside, you can't hear it because it's not running. But in general, yes, they're getting much quieter, much better. If you have concerns, ask the installer if you can go and listen to a previous installation that they've done.
Okay, thank you. That's good. Cindy on Facebook. We're in a detached bothy facing the sea and have a large garden. What space do you need for ground source heating? Any general advice? Kenny, this is about how long does that loop trench need to be? And if you go back to the Inchterdamp church picture with the blue coil, and if you could put that one up, Kenny, any thoughts on scale? You're going to be digging up your garden quite a lot, I think, here.
Yeah, so I'm always a little bit kind of hesitant when someone says they've kind of got a large garden because I have seen properties where like a garden was sufficient space for a ground source heat pump loop, but it essentially meant sort of looping the thing back on itself and excavating essentially the entire sort of footprint of the garden to a depth of 1.5, 2 meters to get it in there. It is a little bit how long is a piece of string because how much space you need depends on the heat demand of the property, because ultimately that's what you're getting out of the ground is heat, and you need to be able to get that heat out of the ground sustainably, because if your ground loop is undersized, potentially you have the risk of freezing the ground by pulling too much heat from it. And that's something that an installer will be able to advise you on. It even depends on the type of soil you have in your area. Sort of water bearing, kind of heavier soils tend to be better because there's more thermal energy there, whereas drier, sandier soils tend to be a little bit more difficult. You need sort of more space. Generally generally, you are wanting a spare field for a ground source heat pump laid in a trench. A borehole could be an option. But again, I would speak to an installer, because there's always the possibility that if the ground conditions are right and if the heat demand of your property isn't that high, you might be able to squeak it in your large garden.
Okay, that's good. Right. Kirsten on Facebook, is solar thermal a good idea for my property with an air source heat pump? 2 showers with mixer taps and dishes by hand. This is about solar thermal sort of topping up your hot water tank, isn't it, Kenny? I think.
I think so, yeah. It's yes. I mean, I tend to think that solar thermal plays quite well with an air source heat pump, because in summer, when the heat pump doesn't really want to be running that much anyway, the solar thermal is going to essentially, a lot of the time, it will meet 100% of your hot water needs in the summer sunshine. In terms of price, I'd be laboring to tell you exactly what a solar thermal system goes for these days, because it's a relatively uncommon technology. Solar PV has kind of stolen its thunder over the past few years. So my suggestion would be get on the Renewable Installer Finder tool. That's something that we can link you to in a moment, and get some quotes to figure out what the price is. Hot water isn't a huge proportion of your energy demand in virtually any household, unless it's very efficient already. So make sure you do the sums in terms of what you're paying for that hot water if a financial return is a main consideration. But yes, in short, solar thermal and air source heat pump, I think, are very good friends.
Okay, that's good. Another Facebook one, Wonky Willow Workshop. Would a district heating scheme system be a realistic option for 12 tenement flats under full refurb? Which type could be useful, and how could costs be covered for rented flats? Excellent question. And my personal feeling with tenements, particularly in dense urban centres, is that district heating should be the way ahead. The Lauriston Housing Cooperative did a feasibility for district heating and came very, very close to doing a pilot on it in Edinburgh. This was probably 7 or 8 years ago now. So I think the feasibility is very good and strong. The snag is the number of stakeholders to get on board is very large. So it's not just the owners of the properties and those who use the properties. It's the roads folk, it's the gas, but it's absolutely everybody. So I think it is a good option for you to consider, but not something I could personally. I don't know. Kenny, any thoughts on that one?
Yeah, so I love the idea. It's certainly something which, from a technical point of view, is feasible. You say full refurb. Going to assume that means energy efficiency improved dramatically. So you could be talking about some sort of kind of communal heat pump, air source or ground source or anything like that. The thing to really watch with a district heating system is the legal arrangements that govern it. That can be complicated, because essentially there will need to be a legal entity that's responsible for sort of operating the system, and you'll need to have heat supply contracts drawn up with each of those flats, and there will need to be clauses in there to prevent people from disconnecting willy-nilly, because obviously if you put this in and then 6 months later half the flats decide they no longer want it, economically speaking, that's not been a fantastic investment. And there's a sort of tricky consideration there, because whichever legal entity is running that district heating system is then essentially a monopoly heat supplier to those flats. So there also need to be clauses in there protecting the owners of the properties from undue price rises. It's something that the Energy Saving Trust have quite a lot of expertise in. The best way to get in touch with them for a conversation on that is probably to go through Home Energy Scotland and mention that that's the idea that has your fancy, and they'll direct you to somebody who can give you some in-depth advice on that.
Okay, thank you. So good in principle, delivery detail, urban scale, a few questions.
Yeah.
Stacey on YouTube, do solar slates work as well as PV or other solar roof options? I don't know. Kenny, any thoughts? Something tells me that these will be, by the way they're fitted, the way they're configured, they're probably not quite as effective in terms of the wiggly amps you get out of it.
That's an excellent question. Actually, I don't know off the top of my head. From having seen sort of solar slate installations and sort of looking at the area of the roof that they're occupying, I have a feeling that they're probably just about as good. My concern with something like solar slates is that the payback period in terms of the time it takes for your solar PV system to generate enough energy to pay back its installation cost um, can sometimes be quite finely balanced. That might be less the
Yeah,
case in
I mean, I,
future
I
with
really
cost of
like the
energy.
idea of it. Actually, I think there's opportunities where it could work really well. And as Kenny said, what it can do is cover the whole roof very effectively. Whereas a lot of solar panels, being standard geometric shapes, normally squares or rectangles, that they miss quite a bit of the roof, and therefore you can get a better square meterage. I think it's all about practicalities of small wires running under roofing battens and things like that. Um, I'm afraid I just don't really know enough to say. Okay, Fayaz on YouTube. How do we bridge the disconnect between SG aspirations for decarbonisation and local on-the-ground planning realities? Fair point. I mean, I hope, as we've indicated in this presentation or this session, and we must put people to the micro renewables short guide, mustn't we? Which I'm sure there'll be a link to that somewhere that somebody could put up. That most of this stuff can be done even in sort of what you might call planning contexts where there are possibly planning limitations. It's more about managing it effectively. I don't know. I think we just have to provide the solutions that fit with the planning regimes that we have, and I hope with the retrofit guide for the building fabric and the short guide for micro renewables, we've given people a pathway in terms of that. I think the technology is moving very fast, and we've not done heat storage, have we yet, Kenny?
No, we haven't gotten through
Right.
the energy storage.
And what I'm slightly hoping is that various emerging technologies enable us to make up some of these deficiencies, whether it's in capacity, whether it's due to whatever the planning situation is, in getting that. I'll quickly just rattle these questions, and then Kenny perhaps can do a little bit on storage, maybe just a sort of big hands, small maps type thing. Fiona on Facebook, would you advise micro renewable technologies are fitted before all possible energy efficiencies are made? Probably not, actually, because in most traditional buildings you've got a performance deficit to make up, and I think I would be suggesting a sort of default set of measures for a traditional building: improved glazing, insulated floors, insulated walls by whatever route, obviously loft and stuff like that, at its most basic level, and then you'll get the full benefit from your renewable technologies. Otherwise they just won't make it. They'll be huffing and puffing, and in some cases using more electricity than you're ever going to save because the building is not up to scratch. John on Facebook, a river, we live next to a river, water source heat pump. Yes, people have done that. There's quite a few places where there are loops, heating coils laid a little bit like in that image with the blue coils, and in the bed of a burn, and then you never run out of sort of water at a certain temperature. Right, I think let's try and do the heat storage briefly, the energy storage, Kenny, and then there's one more question which we'll come back to.
Brilliant. All right. So energy storage, very briefly then. If there is a specific traditional building angle with energy storage, I haven't really figured it out yet. So answers on a postcard regarding that. But to give brief honorable mention to the energy storage technologies that are out there, essentially, you can either be storing heat or you can be storing electricity. What you're seeing on screen just now is an example of some heat storage technologies. So on the left-hand cupboard, you've got a fairly up-to-date, kind of snazzy insulated hot water cylinder. And on the right, you've got something rather more high-tech. It's the box at the bottom. So that's a phase change heat battery. There are plenty of suppliers in the market these days. That one in particular is SunAmp. who are based in East Lothian. And the way that those things work is it's the same technology that makes those sort of kind of clicky hand warmers that you get at the shows work. It's a phase change from liquid to solid that releases heat when you trigger it, and which you can trigger at will. So essentially, you've got sort of kind of at will thermal storage. You can also increasingly get things like smart hot water cylinders, which use the natural properties of water, the way in which water thermally stratifies within the tank in order to function more effectively as a sort of reliable mechanism for storing heat. And you can also consider, in combination with an existing cylinder, with a smart hot water cylinder, something like a diverter from a solar PV system. And what that does is, instead of exporting excess energy from your PV system to the grid, it diverts excess energy into your hot water cylinder, so you're able to benefit from a larger proportion of the system's output. Although that does depend on how much you're earning on your export tariff for that PV system. Depending on your heating fuel, that actually might not be the best option, but the option exists. On the sort of electrical storage side, obviously what we've got are electrical batteries. That there's a lot of companies involved there, Siemens, Tesla, Moisha, etc. and so forth. The most common sort of cell chemistry there is lithium. So you'd be hearing a lot about lithium batteries. They're also the ones you tend to find in electric cars. And electric cars potentially are a sort of domestic storage system as well, whenever they happen to be plugged into the charge point at your house. As long as the hardware is all capable, hypothetically, your car could be powering your house when it's parked in 5 years' time. Now, the reason that I am sort of skimming over this stuff a little bit is because I don't really want to go into the technical details. The take-home message on energy storage, though, is there is no inherent benefit to having energy storage any more than there's inherent benefit to a water tank. The benefit in a water tank is the water that's inside of it. Similarly, the benefit of energy storage is the ability to take energy and move it around in time. So you can't move between sort of seasons. You can't store heat in the summer and use it in the winter. The storage technology that exists just isn't on that sort of level. But what you're talking about is storing energy, say from a PV system that you generate during the daytime, and using it that evening or perhaps the following evening. And that might be beneficial because it might be that if you're on a sort of time of use tariff, which is something that's going to become more and more common, energy in the evening might be more expensive. So you might be well advised to take your cheap energy during the day and to save it to use when energy is more expensive in the evening. Key point though, energy storage is only as good as the economic case that underwrites it. So make sure that your installer runs the numbers and makes a convincing case before you part with your money. And I think sadly we're getting towards the end of our time, so I think I'll invite Roger back to do some wrapping up.
Good stuff. Well, no, thank you for that. Just finally then, I think Krista on Facebook, maybe you email us with your quite technical one there about three-phase supply. Relevant question, probably a lot of time. Kirsten on Facebook, solar panels on the roof, or could they be somewhere else? Absolutely, definitely. Very sensible question. Solar panels do not have to be on a roof. They can also be in a garden, which has a lot of easy access.
Note on that, though.
Go on.
Just because I noticed that Kirsten is asking about solar thermal. Yeah, you can put them elsewhere, but bear in mind that there's going to have to be insulated pipe run to get that heat back to the house. So they really want to be as close to the house as they can get. Good
point, Reg, which makes it kind of the roof handy because then it just goes straight down. Anyway, but fair enough. They don't have to be on the roof, and so certainly solar PV. I've seen many in gardens. Certainly, that's really good questions. We've run out of time to sort of prod the hydro one, which I think is a very fair question, particularly at sort of rural, semi-rural level. The one thing we have in Scotland is a ton of water running past various places, and somehow not using that at an accessible scale for people, I think is perhaps we're missing out a bit. Thank you for your questions. These are really good. And can you give us your feedback at the end of this session, please? That's really helpful for us to know, firstly, how much this is useful to you. Also where you all live and where you're tuning in from. That's kind of really useful and helpful. We've put a link in the survey for the survey in the chat. So if you could just get hold of that. I think if I can route you to the Historic Environment Scotland website, and go onto publications and have a good rummage around loads of energy efficiency stuff and the micro renewables guide. What I think that's probably all we've got time for. We've had something. I've had a question from John on email. I live in a traditional granite building without insulation. I've heard that air source heat pumps only effective on well insulated buildings. Surely they're better than oil central heating, even if yeah, you're partly right. The snag is if you put an air source heat pump in and the building's not performing right, i.e. it's leaking heat, particularly all that lovely warm air you get from your heat pump, you'll spend a lot on electricity, and electricity is still quite costly. So yeah, I think you need to do some fabric work, most definitely.
And the other risk as well is that you end up with an inadequate heating system. It's maybe in a cold day in winter, it's going to struggle to bring the building above 14 degrees, which is going to be pretty miserable. So that's the other risk that you're running there.
Okay, well, let's right. So thank you, Kenny. That's really good. Some good stuff. And if the audience, want to have a second session on this, I'm sure we can fit it in. I hope you've enjoyed it and found it informative. Do the survey as we said, and the next time we'll be talking about dealing with damp in traditional buildings, which is a very, very common phone call that myself and the team get quite a lot. So thanks for joining us and enjoy the rest of your day. Thank you. Bye.
Cheers, everyone.